Hello, my name is Brendan McLean, and I went to the public lecture on Monday, November 30th, which was the Physics of Breakfast with Professor Peter Junker of the Physics Department here at Georgia Tech. I decided to go because I thought, physics, breakfast, it sounds pretty excellent, and the fact that, extra points are always nice, bucket points are good. So I decided to go on that, and I thought it was actually very interesting. The first part of the lecture was all about this idea of the coffee ring effect, and this arises when a solution with particles suspended in it, such as coffee, is spilled on like a table or the ground, and as it evaporates, this ring starts to develop around the outside. It's thick as it gets to the edge of the drop, and it gets thinner as it moves inward. And the physics of it is all about how the droplet evaporates and how it wants to keep the same like diameter and circumference, but as it gets thinner, the water inside the particle moves like to the outside, and this carries the little particulate matter with it, which is in this case the coffee grounds. So as it evaporates, more coffee grounds are moved to the outside and they stick there, and eventually as the whole drop evaporates, it becomes this ring of like lots of particles, and then it gets thinner and thinner, and then it goes to the opposite edge, the particles obviously come back. And I thought that was actually really interesting, just sort of how like the behavior of the water carrying the particles creates this effect that we just sort of take for granted like every day. It's just a coffee spill. And I thought that was pretty interesting. Next, Professor Junker talked about the physics of cooking eggs and how it seems pretty counterintuitive compared to something like boiling water, as they both start out liquids, but one becomes a gas and one becomes a solid when you heat it up. Basically, how he explained it is eggs are obviously full of protein, which is, in a way, particulate matter, and water obviously isn't, as it's just liquid. So when you heat the eggs, the proteins in the solution, the amniotic solution, I don't quite remember my biology, but basically in the solution of the yolk and the white of the egg, the proteins start to denature, as in they come unfolded as to how they were before, and they all start to sort of coagulate and stick together. And as you add more thermal energy to it, they become more denatured. Some of the water starts to leave, but not too much where it like boils off and you get super dry eggs. But as you add thermal energy, the proteins denature and it coagulates sort of into this eggy stuff, which in this case is like scrambled eggs. And it's interesting how that compares to something like water, where if you just boil water, it just boils off and it becomes a gas. Or like in contrast, how you would boil maybe an egg or like cook scrambled eggs and how it becomes a solid instead of egg gas type stuff. After the lecture was over, I was sort of thinking about what I had heard, and I sort of got curious about some of the other things that we sort of take for granted in the idea of physics and food. I was sort of wondering about like why does an apple, when cut and then just left open, why does it like turn brownish, or why does something like guacamole, when left open, turn brown? And so I looked into that. So after some quick research, I found out that apples and things like guacamole turn brown because when they're cut or bruised or smashed in guacamole's case, oxygen is introduced into the plant cells, and this causes a reaction with polyphenol oxidase, I believe is the name of the enzyme. And basically, it oxidizes a bunch of phenol group things. I'm not sure of how the chemistry works, but basically, there's a bunch of oxidation going on, and those things become polymers, which then have a brown color. And that's sort of how the physics and also sort of chemistry of like browning food works. And I thought that was really cool because, it's just sort of something you take for granted, but instead it's this like complex chemical process that is actually pretty amazing. So that was my experience with the physics of breakfast, and I thought it was super awesome.